This episode of Super Baby is brought to you by 4-4 Isosceles Triangle Theorem. In this first episode, the childhood actor Oliver, or Super Baby, will be going up against his evil nemesis, which I will be going into at a later time. What I want you to know for your notes is that you're going to be folding something and gluing it in the top section of your notes, making some conclusions. We'll be doing 2 theorems, writing a proof, and there's some practice you're going to glue in at the bottom that you'll be required to do at the note-taking station. Now, the very first thing you're going to do, revealed in this comic, is you're going to first take your triangle, fold it in half, and glue it into your notebook as triangle PRS with this little midpoint Q. Now I'm going to zoom in so you can see this. What I want you to be able to do is when it's unfolded, you should see triangle PQR and PQS. I should have said PQR and PQS. Then notice my finger here. You should not glue it all the way down. You should be able to fold point S. Here's your point S. All the way over onto point R. So make sure it's not glued fully down, and look at that action. Pow. So go ahead and fold that in the top section of your notes. I'm going to leave this up here. And we will begin our first comic. Well, it all started with this young man over here and his evil nemesis. Let's read the story. Look at that face. Ha 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 ha. I will defeat my evil nemesis, the fox Wawa Peanut, by identifying the properties of isosceles triangles. Notice the isosceles triangles here. This is the evil fox Wawa Peanut, thinking, he will never defeat me. He couldn't ever find at least 4 properties of isosceles triangles. But is there some doubt here? Or could he? Let's turn the page and find out. Then zap! A terrible rocket came from the sky, rushing towards them. Quick, said Peanut, tell me 4 properties you can conclude from this isosceles triangle that you glued in your notebook. Oh my gosh, who made this comic book? It's terrible. Okay, you're probably wondering right now, Mrs. Martinez, do I have to copy this in my notes? The answer is no. The only thing you have to copy down is you should have this triangle glued in your notebook. So this is triangle PRS with a midpoint Q. You should be able to fold it over. And you should have this question next to the triangle. What can you conclude about triangle PRS? Now here's one thing I'm giving you. Triangle PRS is an isosceles triangle. Now looking at this triangle, and right now you're hearing the dog barking, Peanut's barking, trying to get away from the rocket. So quickly we must name those 4 properties. What are 4 things you should notice? The one thing I really wanted you to notice is that when you fold this side over onto side R, point R, these 2 angles, angle S and angle R, are right on top of each other. They're congruent. So one of the things I hope you noticed is that angle R is congruent to angle S. Let me erase this a little bit. Congruent to angle S. You might have also noticed when you folded this side over onto this one, that side PR overlaps exactly with side PS. So maybe you said PS is congruent to PR. That could be something else you concluded. You may have also noticed that PQ, so PQ hits RS exactly at a right angle. So go ahead and draw this right angle in like I did. So you might have said PQ is perpendicular to PS. Now the last thing that I noticed is that when you fold over this corner onto this corner, I noticed that this bottom section is cut in half. If this bottom line, when you fold it over, is cut in half, that must mean that this side is congruent to this side, just like we showed that this side is congruent to this side. Q must be the midpoint. So PQ, and excuse my handwriting here, it bisects side RS. So it cuts it in half. Now, something I hope you can conclude from here. If this is perpendicular and it bisects, so PQ is perpendicular and bisects side RS, this is side RS, excuse me, then that means that PQ is a perpendicular bisector. Perpendicular, can I fit it in? I think I can. Perpendicular bisector. And that really concludes what I want in that top section of your notes. So you should have this glued down with all these marks that we've added and everything we've listed here, including that PQ is a perpendicular bisector, and I hope you fix that to RS. After the rocket came from the skies, Super Baby realized he needed to train if he wanted to defeat Evil Peanut. So he practiced eating stuffed animal dogs. And he just got plain mad. Look at that face. He was just angry. So he knew he had to train to learn more about isosceles triangles. And so he studied Theorem 4-1. It goes a little something like this. If two sides of a triangle are congruent, then the angles opposite those sides are congruent also. So if the two sides of the triangle are congruent, if it's an isosceles triangle is what they could have said, then the angles opposite those congruent sides are congruent also. Here's what they're saying. I would call this, if you're given sides, then you can say the base angles are congruent. This would be my AKA. In other words, if they say that these two sides are congruent, then you should be able to deduce that these two angles are congruent. Given the sides, the base angles are congruent. That would be my AKA. And we're actually going to prove Theorem 4-1 on the next page and further train for the next meeting with Peanut. Listen to that terrible dog. Okay, we're going to start off with a proof, and I just wanted to show you that the diagram we're going to draw is really similar to the one that we did already. I'm going to go ahead and draw it. I'm going to try to draw it. So you're going to start off with a triangle. We're going to have kind of like a dash mark here. This is point A, B, C, and this midpoint is D. And what's given, I'm going to go ahead and move this out of the way. So it's very similar. What's given is that AB is congruent to AC, and also that AD, segment AD, bisects angle BAC. Now we said we're going to prove the theorem, so we're proving that if we give you the sides, we want you to prove, what are those base angles? That these base angles are congruent. So they want us to prove that angle B is congruent to angle C. That's how we're going to prove Theorem 4-1. Let's go ahead and get started by creating our two-column proof. So you should already have started this. Mine has 5 steps, so that'll kind of help you figure out how much room to leave. The given information, you already can fill that in. AB is congruent to AC. We're just recopying this down. AD bisects angle BAC, and that's given. Now the first thing I like to do is read the given information and pull from it what I know. AB is congruent to AC. I labeled that. That's how I should do it. And the next part of the given information says that AD bisects this angle. Now bisector means cutting in half, and I'm going to do something that I saw one of my students do, which is a really smart idea. Even though it wasn't labeled, he chose to number those angles so that instead of writing angle BAD, he wrote angle 1. And instead of writing angle CAD, he wrote angle 2. That's kind of a smart thing to do when you're writing a proof. So if AD bisects angle BAC, then angle 1 is congruent to angle 2. And that is, by definition, of a bisector. the third thing we're going to notice is that these two triangles right here, okay, so I want you to kind of look a little closer. Instead of looking at this as if it were one isosceles triangle, I want you to imagine that this dashed line is actually a solid line, and this represents one triangle and this the other. So I have an angle, a side, and now because of what I just wrote, we have another set of angles that are congruent. Those ones right there. Now if that's true, then right now I can also say, I'm going to change colors here, that AD, this side right here, is congruent to itself. So I'm going to go ahead and say that. AD is congruent to AD. Now I'm saying that that side is congruent to itself because my goal is to show that those two triangles are congruent. And I'm thinking right now, I have an angle, a side. I just need one more thing. Now, I have angle, side. I could have another angle or a side here. How about side, angle, side? There it is. So step 4, I can say that the small triangle, triangle ABD, is congruent, ABD, is congruent to triangle ACD, and that is by side, angle, side. So we just showed those two smaller triangles are congruent. Now that I've shown that these two smaller triangles are congruent, all of their corresponding parts are congruent. That means B is congruent to C. So angle B is congruent to angle C, and don't you dare write CPCTC. You're going to write corresponding parts of congruent triangles, and you can abbreviate, are congruent. Okay, to help finish the training that Super Baby is needing to do to defeat his evil nemesis Peanut, I have one last task for you. Now I'd like you to recall Theorem 4-1 that we wrote above the proof that we just did. And what I'd like you to do is go ahead and write Theorem 4-2. And my challenge for you is, can you write the converse to this proof for Theorem 4-2? Because that is what Theorem 4-2 is. It's the converse of Theorem 4-1. So go ahead and pause the video and see if you can actually remember how to write a converse. Did you pause? Alright, let's see what you did. You should have remembered that a converse is when you take the conclusion and the hypothesis and you rearrange them. So the conclusion should come first. Instead of saying if two sides of a triangle are congruent, you're going to say if two angles of a triangle are congruent. Then, alright, now we're going to put the hypothesis there. Then the two sides opposite those angles are congruent to. That is the converse of Theorem 4-2. Now what I'd like you to do before you do anything else is go ahead and write an AKA for this theorem, and then go ahead and move on to your practice. Now again, I want you to do the practice at the computer, so don't move on until you finish the gluing at the very bottom of your notes.